Hi students, we are going to draw a line inclined to both planes. I have written down the abstract of the question here. Line AB 100 mm long, true length 100, inclination to HP theta is 40 degrees, inclination to VP phi is 30 degrees. The line has got the end A 10 mm above HP and 20 mm in front of VP. There are 5 data given in the question. You cannot solve a question in lines without 5 data. Without 5 relevant data. True length, theta, phi and the location of an end. Location of an end is given by two informations, distance from HP and distance from V. This cannot be directly drawn. This has to be drawn in steps. The first step is, before that, the given end is in first quadrant. We will assume the full line in first quadrant. That's an assumption. The first step is locate the plan and elevation of the given point from the given data. 10 mm above XY, I locate A dash, and 20 mm below XY, I locate A. The plan and elevation of the given point is located. This is the line. The line is inclined. The line is 100 mm long. The line has got the end A in a specific position. The line makes an angle of 40 degrees to HP and 30 degrees to VP. Since the line is inclined to both planes, neither the plan nor the elevation give true length. To see true length in the elevation, the line need to be parallel to VP. It is not. To get the true length in plan, the line need to be parallel to HP. It is not. So neither the plan nor the elevation give true length. That is our difficulty. This is the line. You have located the plan and elevation of the given point. The next step is assume the line is parallel to VP and inclined to HP by theta. The given value of theta is provided and we have assumed phi is 0. When you say the line is parallel to VP, the value of phi is 0. So I have assumed a position as the second step. Assume the line is parallel to VP and inclined to HP by the given angle theta. What is elevation? Elevation is true length. At A dash, draw a horizontal line and at the given value of theta 40 degrees, I draw B1 dash, true length. Theta equals 40 degrees. What is its plan? Its plan is obtained. You know the plan is parallel to XY line, shorter in length. How do you get it? Draw a vertical projector through B1 dash. Draw a horizontal line through A. We get B1. This is a projector, very light. I have drawn it very light. I have projected down from B1 dash and then draw a horizontal line from A to get B1, AB1. Agreed? This line is assumed to parallel to VP and inclined to HP by an angle theta. Now, this is what you have drawn. This is what you have assumed and that is what you have drawn. Listen carefully. If I keep theta same and move B, the line becomes inclined to both planes. You do not know how far you have to move B to get the value of phi. Because value of phi is visible only if the line is parallel to HP. The line is not parallel to HP. So when you move B, the line becomes inclined to VP, but the value you do not know. So listen carefully. If I move B, B can move along a circle, keeping the same value of theta, theta 40 degrees, theta 40 degrees, theta 40 degrees, theta 40 degrees, and so on. B can move along a circle, keeping the same value of theta 40 degrees. What's the elevation of this circle? Elevation of this circle is a line which passes through B1 dash. I call this locus of B in elevation, LBE, locus of B in elevation. I have named this end B1 dash because that is not the final elevation of B. It's a temporary elevation, so I put a suffix 1, B1 dash, and its plan B1. So what does this LB means? LB means that if theta is 40, whatever be phi, the elevation of the end B will lie on this line. It is only to this side, not to that side. It's only to this side. You can see that. This is assumed position. If I move B, the elevation of the end B will come somewhere here. If I move B, it will move like this. It will move along this line. That's why we call it locus of B in elevation. That is one information which you gather in this position. And the second information is, when the line is like this, the plan length is L cos theta, AB1. If it is moved like this again, since length is not changed, theta is not changed, the plan length remain the same. L cos theta remain the same. So I call this plan length PL. I call this PL. That's the second step. Second step is over now. Now, this is the line again. I am going to the third step. What's the third step? Assume the line is parallel to HP with the given value of phi. When you assume the line is parallel to HP with the given value of phi, what is the plan? Plan is true length. At A, draw a line inclined at phi. Phi equals 30 degrees. Whose length is equal to true length. B2. I do not call it B. It's a temporary position, so the plan is B2, A B2. What is its elevation? Elevation is a line of short line length. Project B2 up, draw a horizontal line through A dash, you get B2 dash. This is an assumed position, parallel to HP. You have drawn the plan and elevation. Now listen carefully. This is the assumed position, phi. If you don't change phi and move B up, the line become inclined to both planes. See, you cannot move B without, you have to move B without changing phi. If you change phi, it can be moved like this. No, without changing phi, you can move B in a circle. Phi, phi, phi. B can move in a circle. What's the plan of this circle? Plan of this circle is a line which passes through B2, and I call this locus of B in plan, LBP. Locus of B in plan, LBP. The elevation length, as long as phi do not vary, the elevation length cannot change even if it is moved. Phi same. So the elevation length is L cos phi. So I call this elevation length, EL. Agreed? We have assumed two positions and gathered four informations. What is first information? About the locus of B. If theta is always 40, whatever be phi, this line will contain the elevation of the end B. Second information is plan length cannot change. If theta is 40, plan length cannot change. Third information is if phi is 30, whatever be theta, plan of the end B will lie on this line called LBP. And the fourth information is as far as phi is not changed, L cos phi cannot change, so this length is called elevation length. Now we have to combine them. How to combine them? A dash as center, A dash B2 dash, that's elevation length as radius, cut an arc, B dash. This is the final elevation of the line. Similarly, A as center, A B1 as radius, cut an arc, B. AB is the final plan of the line. After completion, if you draw a projector through B dash, it will pass through B. It has to pass through B, isn't it? The end B, capital B, elevation is B dash, plan is B, you know it should lie on a vertical projector. What does it mean? It means that once you get B dash, you can simply drop a projector to get to B without drawing this arc. So the red lines represent the final plan and elevation of the line AB. Now, after drawing, you see that the final elevation makes an angle alpha to XY line, and the final plan makes an angle beta to XY line. Alpha is greater than theta, beta is greater than phi, and alpha and beta are called the apparent inclination of the line to the reference planes. Apparent, they are not real, they are not original, they are apparent, apparently visible, apparent inclination of the line to HP and BP, to the reference planes. So this is how you project a line inclined to both planes. You have to project them only in this sequence. If you violate the sequence, you cannot draw. And once you follow the sequence, it is very, very simple. It is just like learning the spelling of elephant. E-L-E-P-H-A-N-T. You cannot interchange the letters. You have to say them in the same order. Similarly, you have to do it in the same order. I hope by repeatedly playing this video, you will know the sequence of drawing it. After drawing, you have to mark the dimensions. I am going to mark the dimensions. What are the dimensions? Given dimensions? A dash and A you have to mark. 10, 20. Another information is the true length. Draw a project line, dimensioning line, connect them by a dimensioning line and write 100. Here also draw two dimension lines, put arrowheads on either ends and write 100. This completes the first problem. This is the simplest of the problems you can expect in lines. Simplest of the problems you can expect in lines. True length is given, theta is given, phi is given, the line is in the first quadrant, the location of NDA is given. See it, understand it, hear it again and again, and take dimension and draw and learn yourself. If you have got any doubt, you can ask in the comment box. Okay, we will do some more problems in the next class. Thank you.